We're in Chapter 11, two-sample hypothesis tests. In Section 11.1, hypothesis tests for the difference between two means and dependent samples. This is a continuation of what we did in Chapter 9, where we learned hypothesis testing for one sample data, i.e. when we were estimating mu, just the population mean. And now what we're going to do is we're going to do hypothesis tests for two sample data, where we're estimating the difference between population means. And this is analogous to what we did with the confidence intervals in Chapter 10 with two samples. And if you remember that, there were different techniques depending on whether our samples were independent or paired. Now, we're going to look at independent samples first off. And I'm going to assume, well, I guess this is two sample data, but in our case, this is going to be for two sample independent data. So first off, we're going to state H naught, the null hypothesis, and H1, the alternate, or again, sometimes people call it the alternative hypothesis. Okay. Now, what is the null hypothesis? Just to be crystal clear, the null hypothesis, well, actually, I'll give a little more space here, is that mu1 minus mu2, and almost always it's going to be that it equals 0. It's possible that sometimes if there is some preconceived understanding, if there's some already understood difference, like 5 or something, it could be mu1 minus mu2 equals 5. Typically, though, with the stuff that I'll ask, typically the stuff that the book will ask, the difference will be hypothesized to be 0. And just note that this is equivalent to hypothesizing that mu1 equals mu2. You see how that's the same thing? You just add mu2 to both sides? Okay. Meanwhile, the alternate hypothesis is going to be that it's going to be one of three things, right? Either mu1 minus mu2 does not equal 0, mu1 minus mu2 is less than 0, or mu1 minus mu2 is greater than 0. It can be one of those three things. It won't be two of those or three of those. It's just one of those three things. All right, just to be clear. Or, right? Okay, so anyway, this is equivalent to saying mu1 does not equal mu2. Mu1 is less than mu2. Again. Or mu1 is greater than mu2. Okay? So you might see them written either way. I'm typically going to write them as a difference. Like this minus that equals or not equals or whatever. But you write them however you want. All right. Next up, we are going to find the... I guess so. Yeah, no, I'll use red just so it pops a little bit better. Find the test statistic T, and again, they typically call it T alpha over 2. And again, note that we're always assuming sigma is unknown, so we're always using T and not Z. And it's going to be T, you can just write T, but again, the book writes it as T alpha over 2, and it's going to equal the point estimate, and it's minus the difference between the means, but typically that's going to be 0. Typically speaking, that's 0. Anyway, we divide all this by the standard error, which if you remember from the confidence intervals was S1 squared over N1 plus S2 squared over N2. Okay? So once we have that, we're going to find the p-value corresponding to the t-score with, you remember what the degrees of freedom were? Now remember, technically speaking, it's this complicated formula, and Excel will handle that. But for our purposes, it's just the minimum between n1 minus 1 and n2 minus 1, because remember, n1 and n2 do not need to be the same thing. Then we're going to determine our level of significance, which we always call alpha, and we compare p and alpha, and then you already know where this is going. P is less than or equal to alpha, then reject the null hypothesis, and if p is greater than alpha, then fail to reject the null hypothesis. All right, and then state your conclusion. And then just keep in mind, I hope you see that this is very similar to what we were doing in Chapter 9, with really just that being the difference. And I guess our hypotheses also being the difference, right? The point is that this is analogous, except that we're doing this for two sample data. Okay. So, well, I say let's solve this by hand. Let's see how much we can solve this by hand. We still might use Excel for the t-value. Let's just see what we've got here. Are you smarter than your older brother, right? You can pause this and read the question. We've got this data, and can you conclude that there is a difference in mean IQ between firstborn and secondborn? Okay, so if we're gonna write out our hypotheses, then we would say, okay, first of all, the null hypothesis is that mu1, the mean in IQ between firstborn, minus mu2, the mean IQ between secondborn, is going to be 0. The alternate hypothesis is that we have mu1 minus mu2 does not equal 0. All right, now the way we would do this then, right, I guess this would be step 1. Step 2, right, if we're following along, we're going to find our test statistic, right? We're going to say t, or t alpha over 2, is going to equal our point estimate, right? I'll just write the formula out again, right? It's this guy minus 0, so we don't even need to write that, all over the standard error, which is going to be this guy. Right, and if we do this out, well, I guess we need to plug in a bit of numbers into Excel, right? We will need Excel to an extent, right? So if we go ahead, even though we're doing this by hand, I am still going to use Excel because, you know, whoop. Hold on a sec, here we go. We have this guy, and we'll stick this over in two sample T. There you go. And we're going to put that there. And then we'll take this guy, secondborn data. And stick that in there. Right? And you see that we get our data, right? We get our summary statistics, right? So let's just go ahead and maybe just include this. Okay, so let's just do the t statistic by hand, and then we can check the Excel work to see if we get the same thing. We are getting 101.5 minus 102.4, and then minus 0, whatever. And then this is all divided by 13.64 squared all over 10 plus 9.14 squared all over 10. And what's that going to give us? Well, if we keep it going, we see that we're going to get, I can tell you this is at least negative 0.9 all over, and it looks like we've got some calculations to make. Let's get our Excel calculator right here. right? So here we'll have that this is equal to, let's just do all of it, right? We'll say 101.5 minus 102.4 divided by the square root of 13.64 squared divided by 10 plus 9.14 squared divided by 10, and that'll equal negative 0.17334. Oh. Okay. So we have that, and let's just confirm with Excel, see if they get the same thing. Let's see, where do they have the sample statistic? Oh, they have it over here. Oh, whoops. Hypothesized difference should be 0. And sure enough, look, they get the same test statistic, okay? Now, in practice, you don't need to do all this stuff right here. But I just wanted to show you that you can get it, right? You can get it no problem. Okay? So anyway, we do that. Our p-value, right, for not equal is 0.86. Now, that's not a typo. That is correct. 0.86. I'll just stick this over here. So we got the same thing. Anyway, I hope it's clear what our conclusion's going to be, right? Because really for any significance level, they say use the 0.01 significance level. We would just say, since p equals 0.86, which is way bigger than alpha, which equals 0.01, fail to reject the null hypothesis and conclude that the evidence fails to support the idea that, that firstborn IQ differs from second-born IQ. Okay? So that's how we would do that. Okay? Now, we're just going to use Excel from now on. Okay? So anyway, we have this online testing thing. Remember, we did this with confidence intervals. I went ahead and copied the summary statistics from that over here. So we have, right, the data is right here. So I'll just go ahead and enter this in. So we have N1 and N2 are 35. Let's see, 68.4 and 10.2. 68.4 and 10.2. And again, we're using 2 sample T. Is that 68 point... Oh, wait, no. Right here. Right, perfect. We already have it. 68.4, 10.2. Look, we already have it right here. But we're going to hypothesize that the difference is 0, right? Because if we take a look at what we were saying is, can you conclude there is a difference, right? So just want to reiterate that we have that N1 equals 35 equals N2. X bar 1 equals 68.4. S1, equals 10.2. X bar 2 equals 71.3. S2 equals 10.4, I think it was. Was that right? No, 10.7. 10.7. Okay. All right, so we have that. Can we conclude that there is a difference? Well, let's just write our hypotheses, right? The null hypothesis is that mu1, you call it the paper one, minus mu2, the online score, equals 0. Alternate is that, again, their difference does not equal 0. And we have that since P equals, what does their P value equal? Just snap a pic of this. Since P equals 0.25, which is greater than alpha, which equals 0.05, fail to reject the null hypothesis. And conclude that the evidence fails to show a difference between online and paper exam performance. There you go. Okay. Now, a couple of requirements that we've been assuming, but, you know, we need to just state. Both samples are random. Both samples are independent, right? Remember, that means that they don't affect each other, right? In the case of the exam, we had one set of 35 over here take the paper exams, another set of 35 over there take the online exams. They had nothing to do with each other. They were different people. And we need to know that they're both large or from normal populations. Yeah, that's what it is, right? The same as we did for confidence intervals, right? Okay, and then last but not least, there's this question about empathy difference between men and women, males and females. I'm not sure if it's men and women or males and females, but I'm guessing they didn't test on kids. So anyway, let's go ahead. Let's copy our data and enter our stuff into Excel. Nope. All right, and we're going to hypothesize the difference to be 0. And if we just look at the data, I'll just screenshot that real quick. So first off, I'll post the picture, or I'll paste the picture, but we ought to write our hypotheses first, right? Null hypothesis says mu1, maybe mean for the males, minus mu2. Empathy mean for the females is 0. Alternate hypothesis is that mu1 minus mu2, again, does not equal 0, because, again, it's just is a difference. So that's the alternate hypothesis we're using. And then we'll say, since our p-value equals 0.02, which is less than alpha, which equals 0.05, we reject the null hypothesis and conclude there is a difference between average male and female empathy scores. All right, that's what we've got.